So now you know what molar mass is. So what I want you to understand is how to convert. When a question asks you to convert, it gives you mass, and now they're asking you to tell me how many particles are in there. Now there is no way for us to, when we're looking at this conversion sheet, there's no way that you are allowed to go from between mass and particles. Because mass is related to the atomic mass unit, or molar mass, you have to go through the moles first. So going from atoms to mass means you have to go, let's make a stop through moles. So we're going to use two conversion factors. So first you can either do them in one calculation or step by step. Now, it's faster if you can try to do it in one calculation, and for the most part, I will do them in one calculation because it is good practice to do that. Also, it keeps your thoughts flowing. It eliminates the need for rounding and calculation errors when it comes to rounding. So it eliminates all of those, but it's still, if you feel more comfortable in doing it step by step, those are just extra things that you need to pay attention to, significant figures and rounding, etc. Okay, so you need to convert from mass, then you're going to go to moles, and then you're going to go to the number of particles. So just to review, in order to go from mass to mole, you need to take the mass, times it by the number of moles per mass, and then you're going to take the number of moles and times it by the number of particles for every 1 mole, which is 6.02 times 10 to the 23, Avogadro's number. So here is a sample problem. If you have 350, calculate the number of atoms of silver present in a 350 gram sample. So this is my given, 350 grams of silver. I want to know how many atoms of silver that would be. So my conversion factor would be the mass of silver to the moles of silver, and then to the atoms of silver. So here we go. We start with the mass of silver, and you're going to look for the atomic mass of silver, which is 107.87 grams of silver in every 1 mole. So that's going to be my conversion factor. So here I have 350 grams of silver, times it by 107.87 grams of silver for every 1 mole. So my silver cancels out, and now I have a moles of silver. Now what I need to do is I want to cancel out my moles, so what goes on the bottom would be 1 mole of silver, and in every 1 mole of silver, you know how many particles you have. Avogadro's number. So moles of silver cancel out, and now you're left with the number of atoms of silver. You need to calculate this on your calculator. See if you can do the right order of operations on your calculator, and that is working, because a lot of times people wait till they get to the test to use their calculators and they get stuck. So make sure you punch this in. Let's look at another sample. So you have a solution and it has 24 grams of carbon dioxide. How many molecules are present? Okay, so we're looking for the number of molecules of carbon dioxide. And how many molecules are in 1 mole of carbon dioxide? You guessed it, 6.02 times 10 to the 23 molecules of carbon dioxide. So it's given to you that you have 24 grams of carbon dioxide. You want the number of molecules of carbon dioxide. So my conversion, I have to go from mass to the number of moles to the number of molecules. So take a look. First we have to find the molar mass of carbon dioxide. We know the mass, we want to know the molar mass. So figure that out. You're going to use your periodic table. This is carbon's atomic mass unit, which is equal to the grams per mole, and 2 times 16 grams per mole of oxygen, and that gives you 44.01 grams per mole. So 24 grams of carbon dioxide times it by. So now I have to convert it to moles. What is going to go on the bottom? You want to cancel out your grams, so your molar mass will go on the bottom. Moles is what you want, that's going to go on the top. So my grams of carbon dioxide cancels out. I'm left with moles. Now I need to convert my moles to particles. So for every 1 mole that goes on your denominator is 1 mole of carbon dioxide. You now have 6.02 times 10 to the 23 molecules of carbon dioxide. Ignore this gram here, that's a typo. So your moles of carbon dioxide cancels out, your moles of carbon dioxide cancels out, and you're left with the number of particles. So 3.3 times 10 to the 23. You might ask yourself, your calculator might have had more than just these two numbers, 3.3, but you have to count in your question the least significant, so 2 and a 4. So that's my least significant measurement. And so that's why my answer should be in 1, 2 digits. So we will work on worksheet 4 in class tomorrow.